Okay. Should be live here. Let me make an announcement post and we'll get started. All right. Hi, Jess. Welcome. So, we have a few things to look at. First of all, yeah, so we don't really have enough experiments yet on the baseline, but I have some cool stuff to show you all. Check this out. Oops. Hello, where's my window? Huh? There we go. Check this out. Put this in linear scale for you. This is Sokoban. Now, hello. Okay, yeah, no, the mic works. It's just the camera. Let me just replug the stupid camera in. But here, let me show this first, just in case this is screwing with stuff. I think this is just stupid Windows machine. Bear with me today. Um, so I don't have a full sweep on the baseline yet. That's running now, but with state sets, we get to 54% solve rate on difficulty 2 of Sokoban. So this is a pretty cool result right here. This is a pretty cool result. And this is with like zero domain specific anything, right? People have worked on Sokoban for years. So yeah, they have some pretty crazy chunky models for it, but this is just straight puffer. Let me replug the camera and we'll see if that's stable. I'm probably just going to end up redoing this whole room at some point, but not this summer. Where is our camera? Yeah, this is 147 some odd experiments in. and this is nowhere near the perf that we have now. So we'll see. The hope is that the baseline actually does not do particularly well, but we're not going to wait it. We're just going to let it see. We're going to just wait and we're just going to see whether or not it does what we expect. And we'll actually just sort of have to think about stuff in the meantime. So here. Twenty-four. This is my other desktop. Cool. These are our test tasks. Ends to purge. What other cool PRs we have open? I think NetHack is still in the works. Thank you, Convert. These two are like nice looking M's though to have on the site. For sure. GPU M support is very easy. These are sort of smaller things I was playing with, not a huge deal. I just need to relook at the way we do it, Jess, because I'd like to get rid of reward clipping if we can. I could also just assert that the reward is not out of bounds. That's also fine. Free sweep breakout. That's easy enough. I guess the main thing in my mind, right? It's like I have a bunch of fairly easy things to get done. And I could just decide that, there's nothing I can do until we run full sweeps. I'm just going to focus on that, and we'll see from there. I would like to run a little bit of analysis before I do that. Let me try to just see if I can convince myself of something here real quick. Hopefully this doesn't screw up the camera again. Let's go to Sokoban. I'm gonna mess with my encoder. But I'm basically positive that it's not my encoder. So look at this, right? This is. I can also scale down the preview window a little bit. That might help. Just tune this a little bit and pause the preview. Cool. That'll be fine. So it does look to me like you need to have the curriculum in order for this thing to work. It seems quite clearly dependent on this. It also does seem like you need a reasonable sized state buffer. Interesting with the replay ratio. Horizon as well is at 256. This is the exploration decay. So it seems very, very important that you have a high decay factor. This is the exact result that we want so far, which is from the sweep. It looks like the solutions we found are very, very dependent on curriculum. So we essentially just need to run the full baseline sweep, and if it is truly the case that we do way better with curriculum than without, that is sufficient evidence on its own for Puffer 5. If that ends up not being the case, then we are just confused. And then I have to think about stuff a bunch. I think there's no point considering the failure case at the moment, because then it's just going to be like, I don't know, I gotta go take a long walk and think about stuff. Let's just assume that we're going to get the result we expect for now, and just decide, like, what would we do next? Are there meaningful changes we could make to this algorithm? I mean, it looks like you need to store on the order of thousands of states. Which I believe should be fine with our algorithm. Is there any reason to expect us to not need a top K? Let's just double check codex real quick. I don't know. We'll just use this as fuzzy lit search. Um, I don't think there is anything, but there's no harm in sanity checking. I'm just thinking of like possible problems, right? Like what could we have as a problem from this end? There really aren't that many things we can like ablate. I guess whether or not we anneal a few of the coefficients, maybe. There's not that much to ablate though. Yeah, I've seen this. Success rate is not what we want. It's not generic enough. Wait, is this actually something? Hang on. Purple, yeah, no, we're not gonna. This is some random paper. Okay. I mean, we can look at the PLR paper again. Does it just keep a buffer over all the levels, though? Or, hang on, how's this work? How does the sampling work, actually? I guess actually just like a few metrics on what we're using for the buffer maybe we could ablate. Yeah, that would be fine. Hang on. This is probably what we want. Okay, this is just prioritization. We're live? Yeah, we're alive. So, mm, I think actually most of what we need is in here. Hello, Valo. Hey, Bram. I'm kind of seeing the space of possible algorithm changes though for 5.0. It's a pretty small constrained space. We'll have to run a couple weeks worth of experiments most likely. Nothing too bad. I think Sokoban is a good enough test env. Oh yeah, so Valo, we got very nice sweep results overnight on Sokoban with state sets. Everything looks very good from the data, but we need to run we need to run a big aggressive sweep on the baseline now. So that's what I'm doing. If the baseline sweep fails to do anywhere near as well as the state set one, we're basically golden. And all we have to do is run some small ablations on the algorithm over the next couple weeks. And then we chuck it on Inferno and everything else. And Core 5.0 is done. And if not, then we get confused. This should be strictly more powerful than PLR. So yeah, we should expect this to be a very large difference. Yeah, I think actually the PLR paper probably has everything that I need. So, DB, what the hell is this? What is this? Ah, yeah, I fucking hate this already. I hate pretty much anything that's based on R&D. Yeah. Okay, so let's take a look at their results with that in mind now. What was the best result of the sweep score-wise? Check this out. Oops, I'm on the wrong machine, aren't I? Check this out. So that's better than log linear. It's actually very close to just standard like linear per 54.7 on Sokoban. And it seems like it scales linearly with perf, which is basically what you would expect for this type of an algorithm. Because essentially it's like it's just a bunch of really hard exploration problems. And it just takes a long time to get lucky enough to see the solutions the first time. And that's where most of the compute goes. It's pretty cool though if we convert like if we end up getting linear perf with time, that's a major accomplishment. Okay, look at this. So here's uniform. All right, here's PLR. Wait, train, test. And then on test. Ho ho. Wait, what? Oh, I see. I know what they did here. I see how they screwed this up. Huh. Let me look at this. I think. Oh wait, lower's better here, right? Mean generalization gap. Dude, why would you do this? Why would you do this? Wait, mean generalization gap. The lower is better here, right? Why would you make it so that on this plot higher is better and on this plot lower is better? Why would you do this? And wait, how does this generalization gap? Eh? Okay, this is weird. Wait, train test. Oh, okay, I see. So on training, uniform is also up here. So wait, they're saying there's a big train test gap? That's odd. How many levels do you have? Oh, 1,000 levels. Wait, where's ProcGen? Do I just need to read this whole thing again? I guess I kinda can right now. Y'all want to do paper reading session on this? This one's probably actually worth reading. Because I think this is the closest thing to everything that we need. TD error effectively estimates a level's future learning potential, so that's an alternative metric. I'm basically going to read through and I'm just going to highlight things that I think are important for you all. You always skip the introduction. Okay, so this is state sets to starts of levels. So the approach already should, no matter what you do, be strictly weaker than what we are doing. Do you understand this? So they have to start only at brand new fresh levels. We get to start anywhere. So this is a strictly weaker approach because they're not assuming that they have the access to set the state to anything. Which means if you do have the ability, this should be strictly weaker, and there's good reason to expect ours to be way better than this. So this should be a very low lower bound for us. This is how to think about these things. Okay, we need this term. So standard test eval is training on a finite number of training levels and evaluating performance on unseen test levels. Training levels are sampled from some distribution that we call direct level sampling. Case of a finite training set, you just have uniform sampling, yada yada. Inject to state by default. Convert things that seem obvious now were only obvious because you watched the stream. I think if you ask, like, oh, is it obvious that we should be doing this? I would wager that, like, at least 8 and 10, if not 9 and 10, if you don't lead the question, 80 to 90% of researchers, maybe more, will just be like, what? No. In fact, if you'd asked me a couple years ago, I would have just been like, what? No as well. Yeah, but the thing is, you already have Puffer with Dogfight, right? So, like, the idea was that in general, we're not going to be able to have state-settable environments because of what crap engineering was behind all the RLMs before, right? So the idea that state sets could be broadly implemented and done fairly easily, that is new, and that is something that's been enabled by Puffer. This did not make sense before when people were doing Atari crap. You see what I mean? So, like, the thing is, the state set idea here is not particularly brilliant at all. It's like a very natural next thing to do, but it's only a very natural next thing to do given all the engineering that's already been done on Puffer. State largely the obs? No, not at all. Obs is computed based on state. Yes, and Alpha Zero was considered very limited because of the way it uses states, Jess. Okay, let's get back to this. T is going to be the length of a rollout. Our method is illustrated in figure 1 and fully specified in algorithm 2. Dynamic non-parametric sampling distribution P replay of levels given scene levels over previously visited training levels. I'm calling this A. I don't fucking know what letter this is. A scene. Prioritize visited levels. The replay algorithm is seen as the replay distribution. Through training, our method updates. Actually, let's not be an idiot here. What the hell is this letter? L. Ah, yes, uppercase L, of course. Wait, actually, what is it? What is it pronounced as? Oh, that's uppercase lambda? Well, fuck me, I guess. We've preferred P replay as... Well, that's even worse, because it's L given capital L scene. As replay distribution. This is just P replay, right? The replay distribution. So throughout training, our method updates replay distribution according to a heuristic score, assigning weight to visited levels with a higher future learning potential. This is basically what we do, but with trajectory segments. Using dynamic arrays S and C of equal length to a scene, or L scene, PLR tracks level scores for each visited training level based on the latest episode trajectory as well as episode count. Our method updates P replay after each terminated episode by computing a mixture of two distributions based on level scores and how long ago each was sampled. Okay, so this is like only really useful for fixed number of levels already, right? So this is a very big assumption. P replay, so it's 1 minus P. This is interesting. Staleness. This could be cool. See, I'm actually happy that I didn't read this up front, because this would have biased my design of the algorithm. Replay a level sampled from the replay distribution or to experience a new unseen level. Okay, so they have this, like, seen-unseen thing that we don't really assume. The problem setup of this... So the problem setup of this is very limited, and it's limited because they're assuming training levels. It's very funny in some sense because they actually end up making a much more restrictive assumption than our method in practice, thinking that they're making a less restrictive assumption. Hang on. We employ a function of TD error The expectation of TD over next states. Okay, so they're just summing one-step TD errors or k-step TD errors. The average magnitude of JE. Yeah, so this is what we do. So we can just average this. GE magnitude is equal to the L1 value lost. Okay. Yeah, cool. I like this. Very nice. This is what we're already doing, though. Hello, Tim. Hey, Tim, I got something to show you. Boy, do I have something to show you. Welcome to Boxabon. 54.7 on difficulty 2. Takes 2.5 hours. But there you go. $54.7. Yep, 54.7 is the best one here. Yeah, percent. So the score is a percent. This is like score or perf, right? It's the same thing. Perf is 54 is 0.547 as well. Yes, that's perf with diff 2. Pretty cool, right? So I'm running a big sweep on the baseline now to make sure that it doesn't just turn out that you can get this with the baseline somehow. But yeah, we're solving 54% with Puffer 5. And also, I mean, if you look at this curve, this is basically linear in compute, right? So this strongly, strongly suggests that we can do way better than this just by scaling it up. Didn't need incremental. We'll keep it for now, man. But I don't know. I just went to the difficulty 2 based on my results and experience with the maze ends. Yeah, I know scoring in ink is different. I will say it's interesting here. I do have 13% now so far with the baseline. So something is weird here because I have 13% with the baseline so far. Which is actually quite good for that level of time. So we're gonna have to wait and see pretty much if the baseline is just if it turns out that this just solves. I mean, it would be pretty weird, but we have to run it. Stream went down right when I pushed. That's just internet. There's not really anything I can do about it for now. I ordered Starlink. It'll be here in a week. I'm sick of dealing with the Comcast shitters. Isn't Palo Alto modern? No. They don't even have the fucking cables buried here, man. It's kind of a joke. You have changed the reward. Yeah, Tim. But like, I don't know. The hope here is that this perf is coming from state sets and not just coming from the reward changes. We will see. If it turns out that the baseline is just as good, um, then we have a big problem with 5. We'll see. Just rename the folder convert. You literally just rename the folder for now. It'll grab everything and it'll just use the name of the folder for everything. Using rank prioritization. Okay, this is interesting. This I could try. I could try this rank prioritization thing. Staleness correction's interesting. Ah, see this? I think this is wrong what they do right here. So in PLR, they update the score. They do a hard update on the score. You see this? So they sample a level. They do like based on advantage. They compute new advantage after train, and they update the score. I think this is a mistake because for stuff with sparse rewards, it's gonna take you several samples to see the reward again, which is why I think my decay factor is better. Interesting. See, I think that because they have this thing designed for a fixed set of levels, I think that I think they deal with this crap because they have it designed for a fixed set of levels and they keep it small. Oh, wait, rolling finite buffer of the top levels so far. Okay, this is cool, look. But it's only on mini grid. Okay, they actually do have staleness in here. Figure 3. Figure 3. Cool, we need to spend some time on these. You know, that's a very small... That's a very small delta. You know what? Let me just show you all something kind of ridiculous, right? Because this is probably one of the better, or probably the best curriculum learning paper overall. Check this out. You see this? They basically solve ProcGen um just with hyperparameter tuning. I do wonder if they PPO baseline 1x width. I do wonder if they actually did evals correctly. Probably not. Or maybe they just used the full level set. That would make more sense, right? If they just used the full level set. But they basically solved it with this, and then you get this pretty small perf difference from this whole PLR. It kind of just shows you how important just doing basic hyper stuff is. I know originally this was designed as a benchmark where you're not supposed to tune, yada 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 bullshit. It doesn't matter. The problem was framed wrong originally. Okay, let's see figure 3. Wait, isn't L1 supposed to be equal to GAE? That's screwy. 1E9 is only a billion, right? Yeah. So actually, we're already doing more than a billion, Tim. Oh, wait. This is the best of a 400 sweep run. Yeah, okay, so you're just not getting any signal there because you're only seeing 50 mil steps. Silver paper. Convel STM. The thing is they're getting 92% with a CNN. Presumably they just have big nets, right? This is also on the train set as well. So the gap basically goes away when you have the full full train set anyways, right? Yeah, so we're just assuming we have enough levels. Interesting. Yeah, presumably they're using much more compute, Tim. I mean, like, I don't know how much ours will scale, but it's quite possible that we end up getting somewhere up there. Because we have linear scaling with time, and we're literally using less than 3 GPU hours right now. We're not doing step-constrained bullshit either. Alright, let's figure this out. So, mean test return. Something doesn't make sense to me here. Another useful interpretation. Observation that JE equal to the L1 value loss. Then why are these giving different results? Math needs double checking there. Okay, but they do have this metric at the least. And then they have, what's this, P and beta? They have staleness correction. Interesting. It's kind of screwy in a way, right? Because you're introducing extra hyperparameters on a benchmark that's purely tuned. This is like a poorly tuned, little sketched out on some of this. I gotta chat with Ryan. Though this right here, this is very consistent with the type of stuff that I've been seeing. Right, this fast takeoff. Let's get some ablations. Oh, you don't have ablations? Are you kidding me? Is there an appendix for this thing? Bruh. Wait, there appendix B3. Oh, is it one of those stupid ones where it's like a separate? No, this is not PPO. Does this have the appendix? No. Where's the damn appendix? There's no appendix, right? Wait, this looks longer. Ah, this has the appendix. Okay, look. This is what we wanted. Interesting. They actually have very, very low prioritization here. And then they have this staleness parameter. Interesting. Hmm. Oh, I guess maybe maybe there is something to that. Yeah, we'll have to think about that. That is an interesting thing, though. Extended results on ProcGen benchmark. Any graphs? Uniform. Okay, this is better. It only helps on some of the ends. You see this? Oh, wait, no, are they doing... Hang on. No, because they're comparing to... They have the soda here bolded. Okay, it actually does help way more consistently, you see? It's pretty consistent. Yeah, this is a much better gap here. Okay. I'm happier with this. Do they have another graph with... Oh, they have a lot of experiments. This must have been expensive. Test performance of PLR plus rank prioritization. Okay, so no prioritization is crap. And it looks like any amount of prioritization works, but somewhere in the middle is good. Too much is not great. Gotcha. Hmm, that's nice. Anything else on... I want to just make sure I didn't miss a graph that answers the exact question I had. Come on, have a graph. You don't have a graph, do you? Damn it. Okay, so the one thing I really don't understand from this goal for today, I just generically make progress on Puffer 5. This paper gives us a lot of ideas for things we... Okay, so yeah, we should be live here. Okay, so this is the thing I don't understand, guys. You see they have generalized advantage estimation here in blue, and then they have it here, and then they have L1 value loss, which is very close here and very far away here. Yeah, I know. It's going to be cutting out for a couple seconds every so often all day. I can't do anything about it. Go yell at Comcast. I've ordered Starlink. It'll be here in like within a week. And then I just won't have to deal with this crap. But here's the thing that I really don't understand. So GAE and L1 value loss. Should be the same here. Page 4. Contract in exchange for a stable connection. Hell no. They can pay for that. Oh, is that what it is? Did it actually find it that quickly? Okay, that's actually pretty impressive. They got it that quickly. Yeah, this is the exact chunk of code though. Oh, look, they're literally doing it the same way. It's just abs. Okay, so L1 is this is what I'm already doing. Yeah, Tim, I have Starlink on the way. 85 bucks here for 200 megabits. Which I'm not going to like the speeds that much, to be honest with you. That'll be annoying for a few things with Docker. But, at the very least, it'll be stable, hopefully. Yet California is very weird in that, like, you have a bunch of very normal looking houses that would be 400K elsewhere in the country that are just suddenly worth 3 to 4 million each. And, like, the infrastructure is still the same as you would expect in an area where the houses are 400K. So it's just very fucking weird. Yeah, exactly, convert. But hey, people pay in the tens of millions for fancy apartments in New York, so let's be thankful that those people exist because that means there's arbitrage on things that we actually like. Well, I'm currently at my family's place. 30 acres, yeah. Yeah, that's the way to go, convert. I don't know, Jess. I would personally be happy um, if the cities, like, I think that there are a bunch of people that just want to be in super dense cities and would be very happy if the cities were much denser than they are now. And then there are a bunch of people who want to be nowhere the hell near any of that crap, and we'd be much happier if suburbs and rural areas were much sparser. So that would be the best outcome in my mind. UK mind cannot comprehend. I think that you can kind of just do that in the US, man. Like, there are a number of areas where you can do that, and it's not even that ridiculously expensive to do so. You'll be in the middle of nowhere, but you'll still be within, like, say, 40 minutes of a hospital and 30 minutes of reasonable groceries and amenities. All right, well, this is good. So we figured out this chunk of this myth here. Thank you, Codex. It's kind of funny because look, the wording is a little screwy here because it looks like this is what they're calling JE, but they are using actual JE. So we're already using the best metric. So the two things that we can play with are the rank transform and staleness, which is good. Now, we're not going to like shift this onto politics, though. This is a tech stream, Jess. We will go to tech. 14. Okay. So we're at 14% solve rate on baseline and 1600 uptime. We still have to let this run a whole bunch. I will be pretty damn surprised if this just works. Well, I guess if this just... Let's actually think what this means. If it just turns out that the baseline works and our thing doesn't help, I think it just means we have a very shitty version of PLR applied to segments in some sense. It works for the sparse mazes because that's the perfectly suited task, and then we just have to kind of ablate things until we can get there. No, this is not a white paper stream today. It's just that this one paper, PLR, is very relevant because this essentially does what I want to do for my paper, but they do it over whole levels, whereas we do stuff over trajectory segments. So we should have a much, much more powerful approach than PLR. And they have a couple things in here that I can draw from. In particular, I think that the last hour was worth it because I learned about this thing. Where is it? Where's the rank transform? Yeah, rank right here. Prioritized by rank. So this change in metric alone in my mind is worthwhile. This should be substantially more robust. We can try this next, but I'm hoping that we at least get something reasonable out of our initial sweep first. If it turns out the baselines work, Puffer is great still, and it turns out reward matter. Yeah, but Tim, like, so in my mind, if I were just trying some random thing that could or could not work, like last summer with the off policy, I'd say, okay, maybe the idea is bad. In this case, I am positive that the idea is good. Like, I'm positive that state sets will make a difference if implemented well. And if they don't work well here, it means that we just have a stupid version of using them. Which is a bit annoying because the sweeps take a while to get right. But this was good information. Okay. Baseline won't get that good. State sets has better results in it yet. Tim, I don't think that you'll get anything better out of the state set result. Like, you won't shift the curve up, but I think that if you run it for longer, yes, you will be able to get it to do, you will be able to get it to continue to do better. But, like, that kind of doesn't matter for us for now. What matters is the shape of the Pareto curve. That's the thing we're evaluating. Obviously, for release, I'm going to scale it, and we're going to try to match, we're going to try to shift the curve out as far as we can, obviously. Okay, so that's at least a little bit of progress for now. 16. Yeah, that's fine. So that's a little bit of progress for now. I'm happy with that. Overlay curve, space, and state. Yes, exactly, Tim. Which is what we will do. How many results do you have on Boxman with and without state sets? Would it be work? So, we don't have enough results without state sets yet. We don't have enough on the baseline. So I ran the state set version first because if that doesn't work, there's no point in running the baseline. Oh, it just found a 19. This just found 0.19 on the baseline in 3600. Yeah, we only have 194 results so far in Boxabon. And we have, I believe we have 600. Oh, it's actually not that many more. It's 279. I guess we could go grab it real quick. No harm. What do you consider more complex? So, there are two versions of that liberty. There are complex environments from a benchmarking perspective that are like, I, as a researcher, based on my understanding of RL, am very confident that these are high confident, like that these are good environments where doing better on them is very indicative of results elsewhere, and the ends themselves are hard. Then there is these ends look pretty and impressive to other people. Those are two very different things. Um, we will do some of both. Obviously, we focus on the actually informative ends or core research, and the showcase M's are needed for us to still have a business and people to hire us because not everybody's an RL expert. So sometimes you have to show people things they can understand. Um, in my mind, Sokoban is very, very much like a core research environment. Um, it's a very, very hard env. It's dramatically harder than pretty much anything that I've gotten from a client, and perf here will transfer well. Oh, and then I have to move breakout, don't I? We'll just do it like this for now. Ooh, okay. So we're basically, we have to see now, right? Yeah, so if this curve goes out this way, that would be consistent with expectation. We have to wait and see what happens when we get more of these runs. If it ends up like this, I will say that would be consistent with 2048. Based on the gap, we'll know where we stand. It's harder in the sense that the learning problem itself is harder than client work, Tim. There are a lot of externalities with our professional work, right? That like the problems tend to be a lot messier, but then the actual problem, once you get it set up correctly, is much easier to solve. Peace, what are we puffing? We've got Sokoban based lines running now. We're essentially testing first version of the Puffer 5 algorithm. And what time is it? 12:30. I think there's really not much for me to do other than wait on the experiments. I think I probably should just start merging in some environments and playing with things. Well, I don't know about merging. I guess we can kind of just play around with Crafter and Craftaxe a little bit, as well as Overcooked. I'd very much like to have those on the website. I think that would make sense to do. I'll be right back. Some of the kernel stuff. Kernel stuff is pretty heavy, Jess, and merging that has the potential to mess with other things I'm doing. I don't want to have any possible reasons that our experiment results get screwy, and I don't want to merge, like, I don't want to touch that until I have the 5 algorithm stable. I think I'd rather do some env stuff, um, while we wait on the other experiments. Thank you very much, Tim. Either way, this will be a very, very useful research environment, so this is a great contribution. Coding game env. Coding game. If it's text-based, it's not a good fit for Puffer. I'll be right back. Oh, wait. Coding game. Maybe I'm thinking of the wrong thing. I'll be right back. All right. AI bot programming challenges. Um, if you can set it up such that do you need to script the bot or can it directly be controlled by low-level actions? If it's the latter, then sure. Did you already play with OSRS Inferno? So Inferno is Vala's project, and it will be a core test engine for Puffer 5, but it is a big enough project with enough moving parts that I would prefer to test on Mazes and Sokoban first. And then think of it like this, right? We're going to essentially use Mazes and Sokoban as the dev set events, and then we'll test it by running a sweep, but not having to change the algorithm at all on Inferno. My tissue. Yeah. All right, let's get on to. We'll do stuff on a combination of the local box and Puffer Max, I think. And then we'll essentially Overcooked and Crafter, I believe, will be the ends. Do that. Oh yeah, also let's just make sure we're still SSH'd in here. Let me check the Vast credit so we don't drop the box. $163. Okay, we're still good for a few hours. Many hours, actually. Yeah, okay, Convert. Jesus. You know all that grass in those 30 acres? Go touch it. Okay. This is the nice one. Yes, Jess. That's why I stuck Spencer on robocode. Okay, cool. We're good now. We can just start on this. Anything here? No, we don't need this anymore. Got Overcooked and CraftX Classic. I guess we should probably start with this one. Are there tests in here? Yes. This is codexable. It's already set up for this. I'm not going to manually edit the AI gen code. fuck? There we are. Actually, this is what we're gonna do. Here. We're just gonna write like like a simple spec of what changed in 4 to 5, and then it'll just be easier to do this on all the ends. Here, this will be easier. Internet blipping literally every other minute is awful. Hello, Nish. I don't think I'd be able to go to South Korea for the conference. Deadline was 18th. Wait, what? How can they have... dude, email them, because how can you have found out about the paper now and the deadline for applying to the conference be before that? Because the travel grants are supposed to prioritize authors, right? That makes no sense. Just email that. Figure out how to email and write them a short but polite email on that. Say, like, hey, I'm an author. I won't be able to attend the conference if, I don't have a grant. Obviously, I wasn't going to know. I wouldn't have known to apply to this thing if I didn't know the paper was going to get in, yada, yada. If you politely explain your situation, quite possibly. Some M's are not updated to 4.0. All the core M's are updated to 4.0, Bram. They're like some unfinished ones and some very minor test M's that weren't updated, but like pretty much all the core stuff is there. That's it. So, to give you an idea as to what I'm doing and why I'm letting just Codex do this, the updates to Puffer 5 are very easy. They're essentially, there's no room for screwing with them in some sense. Like, there's kind of only one way to do it. Um, there's minimal stuff you can screw up in the process. So, this is fine. Check on this in the meantime. Okay, this is still the best result so far. 203. So it's got like another 60-something experiments to run for parity. Wasn't Puffer 5 planned for Christmas this year? Puffer 5 will be earlier, Anish. Puffer 5 will be end of summer. Unless, like, all hell breaks loose on the algorithm side. But basically, we'll know that by today. Like, if there's a substantial gap in performance, like if state sets does substantially better on Sokoban, we are essentially guaranteed that all core work for this update is done this week. And, you know, just whatever else we figure like putting in will be smaller, like nicer, like nice small things. And like will be well done by the end of the summer. This is so funny. So I have this side tab here. And hang on, there's somebody in the lab that started like that was in my lab Um, yeah, there was somebody in my lab at MIT who started playing RuneScape after me and just really, really plays the game a lot. What in the fuck? Okay, this is actually just like a disgusting amount of gameplay. What the fuck? Let me not leak the username, but okay, started playing after me, is maxed, has done post-max pet hunts on multiple skills, it looks like. Has many, many thousand boss KC. Yeah, this is pet hunt KC. Jesus. 580. Okay, that's just obscene. Jesus. Not sure if has graduated yet. Presumably so, but Jesus Christ. I mean, that's gotta be like 6 hours average a day. Crit, you have a very overinflated view of MIT students. Yeah, Anish, like literally, right? No, I'm not an iron. This is a main. Mine is a main. That's not my account on the high scores. This is mine. Almost 99 mining. I have a I have probably way too many hours in this game as is, but at least a good chunk of them are like side monitor content. Um I don't know, Anish. I found a lot of the people I met at MIT to be very uninspiring. Are you doing puffer to it? I mean, we are actually doing puffer on RuneScape environments. Like, that's going to be one of the main tests for puffer 5. We've got two separate people that have now ported collectively close to 100,000 lines of code, of like private server code from RuneScape over into C. Obviously, with that amount of code and that few people, it's very LLM crappy, but it's one of the things that is very verifiable, and it's done by people who actually do understand what they're doing. So it's not just like vibe coded complete crap. And it's going to be very efficient as well. How do you side play? So this is literally, I click this like once every minute or two, and quiet so it doesn't distract you. Obviously, more complicated stuff than that would be distracting while I'm working. But the game is kind of set up so that there's a lot of stuff like that in it. Let me fix the camera. There we are. This thing. You learn C, dude. It's not short of learning C. You just learn C. I know camera froze. I fixed it. I unplugged it because it fucked up. There's some driver shenanigans. I put it back. It should be fine now, right? At least it was frozen. Before I had it unplugged, it was frozen on my screen. Maybe it wasn't frozen for you guys. But whatever. Now it's fixed for both. What in the hell are we doing here? Okay, this is fine. This is just moving things. So... I don't like these macros. So you see, even for something like this, I still have to just not brain off, hit tab, 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 right? Because it'll do stupid shit. Like, look at this macro crap, right? Oh, yeah. Pepper. There you go. That's what you need. Whoops. I'm going to be honest, I've never even read that book. I got it recently, but I've read pretty much no programming textbooks ever. Like, obviously, I've like done a bunch of formal learning on everything, but I've never been the type to get my information from like really long textbooks. On towards Zuck. No, we actually, so it's between the two contributors, there's going to be Fight Caves, Zuck, Zulra, and PvP. And then it's set up so that you can add new ends as well. I've barely started it, Jess. Okay, this is good. It realized I'm going to bitch at it. So it's starting to do smaller things so I can, like, review them. Yep, this is correct. I'll do Awaken Vard. I'm gonna be honest with you, our model will smash Awaken Vard in, like, probably 30 seconds. As long as you get the observations right, I'll be surprised if it even takes 30 seconds for it to learn Perfect Awaken Vard. It's just not that hard for, a model. And I still can't do that boss on the main game. It was a total bitch even on leagues. No, Brom, there's probably quite a bit we can do to improve the speed. Like, we've had a couple people look at things, but as far as kernel development goes, I'm quite amateur at that. I have a lot to learn. I'd also like to make sure that we keep stuff simpler in the process of making it fast. There's probably still quite a bit of room, though I think that the biggest room that we'd have at the moment would be we'd have to come up with some improvements to the map moles. There's probably just like some settings or whatever that I haven't played with yet. Because we don't have kernel search, we're not even checking like launch args or anything. Where's the RNG? Ah, I see. It's good. $22. Okay, this is starting to find better stuff. We will see whether we have big advantage over baseline. I do hope we do. Okay, this actually we're gonna have to review. It doesn't do anything dumb. Yeah, this is not terrible. I try an ish. Oh wait, I missed him. How feasible do you think it would be to string those RSMs together? Yeah, that's kind of the idea longer term, Jess. Gauntlet from beginning to end. That would be a good one. And I do think it would be able to do that. Like, we're doing Inferno, right? Inferno's much longer than Gauntlet. Speed increases mainly GPU, ink-based ocean speed. There are some changes for ENV speed that would help. We have a couple things landing soon that will help, like, a bunch of ENVs. One of the big ones right now is decreasing bandwidth. So we're going to probably land soon B-float observation encoding. That will help. There's probably some stuff you could do with our threading model as well, though it's a little complicated. Okay, you see that here. So it looks like it's changing a lot of code, but if you look at what it's actually doing, it's basically just swapping in env, which used to be the full struct, with s. This is actually a very simple refactor. I'm just making sure it's not doing anything crazy. This is a little bothersome, though. 2600 for 22. I mean, that's right on par with our existing stuff, man. Maybe a little lower. We'll see. We will see. PvP has learned to game all scripted policies by maging from 10 tiles away with Mage Prey on. Eh. The funny thing is that's the type of stuff that you actually do in LMS when they when they deploy new bot scripts. I've literally done that before, man. Like Farcast with Mage with crossbow on. I've literally done that shit. That's actually pretty good. I'm pretty sure they're actually there. I distinctly remember this now, actually, right? Because it wouldn't know how to put its crossbow on long range, so it would just stand there. If you would just you keep protect mage on, and then you mage from 10 tiles away. Yeah, it literally would do that because it will never hit you on prayer. I mean, this is the type of cool stuff, though, that you know when you actually play the game. Like, that was actually a strat against the bots. There's also the one tick, like just you one tick everything. So you basically ignore everything and you just one tick your whip. That was also one for a while because it never tries to predict. It always just matches one tick delay. We alive? We're back alive. Literally, at least I get a disconnect at least every hour, but I'm getting micro bumps like constantly. Annoying as hell. Alright, let's just review this. Wait, I did this one. What's the next one? This is fine. Yeah, look, it's just n replaced with s, n replaced with s, n replaced with s. This one's a little screwy. That one's a little screwy. We'll get a diff afterwards and we'll min the diff. I mean, that's a good thing, right? The goal is not to bot the game, right? This is for research. Why would I want to ruin my favorite game? Depending on how good it gets follow, it would be really cool to see if we could get one of the like the good NH stakers to see if they can beat it. Oh yeah. Um I definitely want the bots out of the damn game. Some of them really, really break stuff, like the Doom bots especially. Those need to just be gone. It's sim to sim, Volo. I mean, or we could make the client decent enough that, like, they could just play it. Yeah. Yeah, I've thought about it. It's not really a good RL fit problem, Jess. Includes the env header as C++. Like data in actual fights. Eh. Oh, it gets a whole bunch of crap at the moment. If the rank transform thing worked, that'd be very interesting. Why did it try to build this? Dummy. Sure, you want to do it this way? Whatever. Nice. Looks good, right? 2.5 milstep per second training. I started watching. The math is going over my head. What's your math background? So, like, the only real math in 231N is derivative. You need to know what a derivative is. Um, yes, it's multivariable, but, like, it really doesn't get much harder as a result. I guess there are cross terms for some things. Multivariate derivative calculus is useful. You do need to understand the fundamentals of that. You're not going to be working out a lot of derivatives by hand, though it actually does come up. Well, high school math can mean a lot of different things because I'd seen that through high school, right? Multivariate derivative calculus is something you need. Mind you, that is, in some sense, that's the most accessible piece of math because it's fully mechanical. There's no art to it. And in particular, the way that it is applied um, in ML is very, very simple. You will have to actually do the exercises in the course, by the way. You can't just watch the lectures. Like, you gotta go implement some layers and stuff. Okay, so this is nicely ported now. Cool. Yeah, and that's the annoying thing with having to do local state obs. But rendering is just so bloody expensive, and even if you did render, the obs would be so large. It's pretty much always worth it to just extract state. So this is nice, right? And get both of these M's ported up. Okay, it's not adding macros. That's already there. Having local state almost feels like cheating. I mean, not really, Valo. Are all your boxes down? You have like 10. No, they shouldn't be. What's wrong with the boxes? One, two, three, four, five. We've got 5 of the single GP ones up. I've got 2 extras of those. So that's 7. And then one of the tiny boxes is up. The reason I'm doing shit on Vast is because one of my multi-GPU boxes is down. Unless I've gotten a reply to this. Either way, I'm going to have to finish this run. Okay, actually, I did get a message today, so we'll see if this comes back. Lovely. Thank you for reminding me. That was very useful. Thank you very, very much for reminding me. Yeah, puffer boxes just have 1 GPU each. Tiny box has, those have 6 each. So, thank you very much for that. Cool. I actually can do other things today. Very nice. It's also just dramatically more convenient to have my own hardware than to have to use shitty Vast. Yeah, Valo, I wouldn't worry about visual stuff, to be honest with you. Like, so much of RL has been done on Pixel M's. It works, it's just slow. That's all. There's really nothing to it. In some sense, state estimation is the easiest damn thing to train. Architecturally, many things get easier with pixels, they just get slow. Heh. Yeah, I can tell that this was written with Claude or Codex. The same as just seeing the piece positions. I mean, Not seeing the board. Yeah, I don't think it's a dramatically harder problem, Valo. I think that you learn, like, those correlations you learn very easily. You just burn compute. Like, I don't think you change anything at all about the method. I guess if you feel like it, you can train, like, you can train a basic encoder for it. But nothing really changes with pixels other than you burn GPUs. I might get rid of the 3090. Wait, mine has... Wait, Tim, why don't you... Wait, why don't you just plug your monitors in? If it's your local desktop, why don't you plug your monitors into the 3090 and then use your 5090 for sweep so that you don't lag your screen when you run experiments? That would be the easy thing to do. Alright, so we're just deleting all of the memory allocations because it's all going to be static. Did I just see Riot open? That was weird. Uh, okay. I gotta merge one of Jonas' PRs still. Okay, this only has like 50 more experiments. It's only got like 50 more experiments, so we'll see if this is gonna be as good or not. Kind of gross, but At least our box came back up. Blah, 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 blah. Stupid jicks. We're gonna finish this one. Probably do Overcooked. Maybe sweep this. I mean, realistically, right? We've got two M's here that we can use. We have Overcooked that we can use. I still don't think these are going to be... Well, who knows? Maybe Craft Axe will be a good benchmark end. I think Crafter is too easy. It'll look cool, but it'll just be a showcase end. I think Craft Axe, if it's fast, though, will be good. Oh yeah, Robocode will be a nice env. Though I don't think that'll be a showcase env. That's kind of in the middle. I guess if it learns really cool looking self-play policies, maybe. Convert, I have enough stuff to do without beta testing the envs. When you have it ready, though, I'll be happy to look at it. I think this one's heavier, right? Oh, no. Oh, it is heavier. 54% env time. Yeah, this is just stupid small network. Okay. Cool. I'm gonna use the restroom real quick. And we'll see what env next. Be right back. How much do you bench? PR is 275. That was about a month ago. I'm on a bit of a cut now, though. That was probably I weighed 185. I'm mostly running at the moment for the summer. Hang on, I just want to get my thoughts clear here for the 5.0 update. Too many wires are getting crossed in my head. So we do need to update all the M's. Other than me having to make sure stuff doesn't get screwed up, that's mostly just codecs. So updating M's, very easy, right? There are a few small tweaks we have to make to our end format that we probably want to do before I port too many of the M's. That's no big deal. We have a few demo M's where we basically just have to run a sweep and test it. It doesn't particularly matter if we do that sooner or later. I think it's probably even better to do that later so we have sweeps on the release version. There are a few other small things we can sweep, to be fair. I could sweep breakout without reward clipping. I mean, there are two things that we want to test on the algo side, right? Like, it's not that complicated. I can actually, what I can do is when I can finish this, and then I can get that one set up. What's robocode? The robocode is this old programming competition environment that was used in a lot of Java courses that for like new programmers, but then a lot of slightly more experienced people would build really good bots for it. It's this 1v1 typically, or like 1v multiple whatever tank battle game, and the dynamics are pretty nice, and I figured it would make a good self-play environment. I started implementing it a long time ago. Tosin made some contributions to it, and I had Spencer work on finishing it. Any weight loss drugs on the cut? No. Just like run and not eat a lot. I mean, look, cutting is easy for me. I have a very low appetite to begin with. So, I mean, in order to gain weight in the first place, I basically have to stuff myself. Like, in my mind, that's the easiest part of any of it, right? The hard part is doing the training on a cut. This one is not going to be as bad as last summer. Last summer, there were some extenuating circumstances where, like, basically I'd gained enough weight that it would have, I got to a body fat percentage that it would have been virtually impossible for me to get to naturally. And actually, in that case, there Yeah, just last summer was brutal. This one's not as bad. This is like a 10-pound cut, most likely. And the extra 10 pounds this time was pretty much just from me not having the energy to train enough and not wanting to lose my muscle. So just like basically force feeding myself a little bit too much to not lose muscle during the Puffer 4 development. And this was the plan anyways, was to do that and then cut in the summer. Okay, this is fine. Okay, we'll commit this. And then we'll set up the experiment on the other machine. A little sketchy to try them on different machines, though, isn't it? Eh, I think it'll be okay. I think it'll be all right. Do you just not like food? I just don't have the appetite to eat 3 to 4,000 calories worth of food. Like, it's moderately difficult, I guess, for me to do a 1,500 calorie cut. But if I did a 700 calorie cut a day, like I wouldn't even notice that. That would just be like, oh yeah, I'm not stuffing myself. I'm eating the actual amount of food that I want. And that would include just eating random pastries and shit as well. Robot rage. Let me look this up. Wait, what is this? Oh, it's like a 3D tank bottle. Interesting. It's like a 3D tank battle game. Hmm. I'd never heard of that one. Well, it's a little irritating to me that now we're gonna have the experiments on different machines. I think it'll still be good enough. Let it do this. And then what we'll do is we'll set up a new set of sweeps on this. Okay, we're still at 22% with the original algorithm. So I wouldn't be mad about this. If it essentially turns out that the state set method as it is now essentially just helps you with long runs. Well, this will be really good data though either way, won't it? This will be really good data. Oh yeah, it can do whatever it wants. This is just tests. These are throwaways. I look at this as just like, increase confidence that nothing stupid got fucked up with simple routine refactor. Not like for sure nothing got fucked up, but we should be okay. And I also checked all the code changes. Um, Everything looked fine. Cool. Yeah. So what we'll do is we will. Didn't I have something running here actually? I did. Okay, let me deal with that. Okay, so this was supposed to be without Aurora? I see. Do like this. Okay, we've got Sting. That's weird, isn't it? I don't know why this is running experiments way the fuck out here. Let's do uptime limited to 130. Hello? I don't know what's going on with this. There we are. So the baseline is a little better here, isn't it? And also the sweep is just very screwy on this. So I suppose for now we just keep the optimizer changes before we can validate them more extensively. That's fine. Oh yeah, we don't need to, we're fine here. So we just go like this. What's up, Tim? You still important sample, correct? You would, right? Yeah, Casper. So that's gonna be that will be added to Puffer 5. It's a very small, easy change to make. Um it will support different types of EMs, but like most of the game type EMs we use for testing don't need it. That will be more useful for the types of things that we plan on doing with full stable RL. Like once all of our stuff is super good, super stable. I mean, it is compared to everything else, but I mean, the bar in my mind is RL is a mature, stable field that just works. And then that is when the environments that will need GPU acceleration become relevant. And I'm not referring to simple robotics problems. That shit we could do now very easily. Yep. And launch one more experiment off of this. Please tell me that this is still reasonable. So far, so good. What would require GPU anyways? So my top interest long term, um, my top interest longer term is biological sim. So I think also material science simulation will be cool as well. I don't know anything about these areas other than people use a bunch of sims and they use them in a very primitive way. And probably having sims that can optimize towards an objective will be useful. But I don't like the reason I don't really want to go into it too much yet is because or is that in my mind you want to be approaching hard learning problems where interpretability is limited from a point of RL is stable and just works. And we're going to be very, very close to RL is stable and just works very soon, within this coming year. Fuck. What the fuck is this shit? Not fully sorted away. I see. That's a problem. I transform in staleness, eh? So they're essentially, from reading the PLR paper, there are two things that jumped out to me that we could potentially change in the algorithm. One is applying a rank transform to the absolute advantage estimate. That just like replaces each value with the index of that value in a sorted array. And the other one is a staleness factor. So upweight stale values. Though I actually, that one doesn't make as much sense to me. Let's see what we got here. Okay. That's fine. Yep. Wait, is this fucking using bubble sort? Yeah, we're gonna have to see what the hell's going on with this thing. This will be easy though, right? We'll just test the breakout speed after and see if it's stupid and slow. That's easy. This is fine. I am a little worried about this one. I mean, it's gonna get less than 50 additional experiments to run. I am a little bit concerned though that if you just sweep it longer, maybe it finds better stuff. That's kind of the point of the whole thing, Casper. There are not really many places where this level of science just happens in the open. And it's actually something that you can just start contributing to right now if you feel like it. You know, many of the it's all open source. Many of the contributors came in with zero AI experience. It's a great place to learn ML, RL, low-level programming. The minimal useful contribution, like the bar is not that high in the sense that a lot of relatively simple to implement environments end up being useful. This version is still fast. I don't think that this is actually using sampling, is it? Can't follow what you do. Well, I mean, you're not watching the easy parts now. Like, I'm not always working on easy stuff. To be fair, what I'm doing now feels pretty easy for me, but like, this is based on 3 different papers that I have in my head, right? And a whole bunch of experimental results that I'm constantly reweighting the evidence of. But BS. We alive? Yeah, we're alive. Stupid internet, man. Heh. I thought it was doing fucking bubble sort. I saw that and I was like, is it bubble sort? Yup, it's using bubble sort. How we doing on the baseline? Oh, it just got a new one. 28%. 2800 uptime. I don't know, man. We're gonna see. The baseline is doing surprisingly well. I mean, we expect there to still be a big gap, but who knows? I have more things to test. What does that say if the baseline does good? Um, I guess good point. It says Puffer's freaking cracked. No, there really can't be any major info fuck ups as far as I'm aware. See you, Tim. Oh, by the way, this thing is clearly, PhD level intelligence and everything. Implements fucking bubble sort. Um, I actually think that in terms of like at least addressing the major challenges that are preventing RL from being broadly mostly out of the box, I think we're within a year. Jesus fucking stop this shit, man. In my mind, Crit, like, I think that for basically any medium complexity problem that would have previously taken a year's worth of work by a domain expert, we kind of just solve it out of the box, given a reasonably set up env. I mean, this is just incredibly stupid, right? It basically goes and sees an obvious C99 code base and tries to use fucking C++ algorithm. Like, piss off. I'm gonna restore, hang on, let me see. I'm gonna restore heap behavior. Or admission. Does that make sense? No, it fucking doesn't, right? Internet. Stupid thing, man. HD level intelligence, my ass. What are we doing? Yep, that's it. Yeah, whatever. It's funny. I'm not fucking thinking correctly. I don't care. It's whatever. It just occurred to me. It's very funny. Is it still using fucking bubble sort? It's still using fucking bubble sort, isn't it? Yes, there is a built-in C sort. There literally is. It's literally bubble sort, right? Am I seeing shit? I literally gave it the architecture and it still comes up with bullshit. Like, this is the simplest damn thing ever, right? You have a bunch of stuff, it needs to be sorted, but all the appends happen at the exact same time, so you just make the buffer longer than you need, and you sort it once. Easy. And then you only look at the top K elements. It's so easy, right? Okay, this is better. And now it calls qsort. You see this? That's what you're supposed to do. You write a little comparison function like this. It's a little annoying, right? But you write a little comparison function like this, and then you just call the CQ sort. Super easy. Look, I mean, importing algorithm is forgivable because it is a CUDA code base, so it just assumes, oh, I can write C++. It doesn't realize that it's supposed to be CUDA C. But implementing fucking bubble sort is batshit. That's insane. So codecs can be PhD level intelligence under human supervision. No, codecs can output useful stuff when micromanaged by a human PhD. We don't even have a heap anymore. What the fuck is this shit? Okay, it's just updating comments, whatever. I don't even want to, like, spend too much time on this, because this is literally possibly all throwaway, right? Like, this is just us testing an alternative heuristic for sampling from the PLR paper. Jesus. Are there any ocean M's you would like optimized more that no one else is working on? Optimized more. Ooh. Well, it depends how much you want to get into stuff. So, hmm, the one that would be really cool that comes to mind, we have this Impulse Wars environment that uses Box 2D, and it would be a really awesome env, but it's just too slow, and it's also like probably thousands of lines of code too long because of Box 2D. Now, evidently, Box 2D is actually supposed to be very well optimized, but a lot of what it's doing is opaque, and I suspect that there are a lot of shortcuts that could be taken. It's based on it's Captain Spacehook's M's. It's based on Retrograde Arena. 4.0 changed it heavily. No, it didn't change heavily on the environment side, Pepper. Like, wait, what do you mean if I'm not using pufferl.py? If you're not using pufferl.py, then you're going to have to use our vecenv implementations. Because we no longer expose individual environments at the Python level. We have a vecenv exposed interface. And the ends themselves, it's pretty much just like the rewards and terminals become float type, actions become float type. You have to manage your own RNG so that stuff is reproducible. And then there are a few changes to how we do the bindings. I want that Python exposed. You don't, because as soon as you expose the Python, you're looping in Python and your perf is gone anyways. Well, why aren't you using pufferl is my question. Like, just using our M's without using our training code, nothing is going to be remotely close to as fast or as good as our training code. Okay, this is fine. 1 to 2 mil. Yeah, but like, our algorithm is not just PPO. You're within 90% of puffer, like on hard tasks, because PPO is not within 90% of puffer on harder tasks. Our algorithm has changed quite a bit. Heck, even the architecture in 4.0 is much better. Now doing the whole performance thing. But like, what do you mean you're doing the whole performance thing? Like, what are you trying to do? Like, what are you trying to do with custom pufferl? Config driven. Oh, geez. Good luck. Um, yeah, PyTorch is in PyTorch cannot get within a factor of 2 or even I don't think 3 of our current perf. I mean, I literally just sent a client an update this morning where I ported their env to 4.0 and training got 4.5 times faster for the same level of perf. It's not just going to be because of dictionary overhead. Like, we can hit 20 mil end-to-end training. We can hit 40 to 60 mil inference. I think maybe even more. I haven't even bothered testing that. How is this 16 mil? Am I an idiot? Am I on the wrong fucking machine? Huh? Snake I haven't messed with in a while. Bot will unnecessarily send like 2 fleets of 4. Why do you care, Jess? If it's sending them 1 tick apart, like, why do you care? Min heap is not cheap. I guess this we could try. More math for the env to run? What do you mean, more math for the env to run? Oh. I'll just make the env fast enough to not care. Whatever. Then you're fine. Just like, why are you so worried about that, man? There's way more important stuff you can care about. Interesting. Cool. That's cool. Great. Where's the sort? I swear if it snuck bubble sort back in, I'm gonna flip. It is Q sort. Good. Much better. Still some overhead, but better. Enough to test it, I'd say. Uh, Internet. Good. Okay. See what we got for Boxabon. Not bad. So all we do is we leave it on this. Right? Oh, actually, no, hang on. We leave it on... Yeah, on this. And we leave this, and we're good, actually. That'll just sweep correctly. OBS, come on. For folks who didn't hear earlier, I did order Starlink, so the internet situation will be resolved within the week. But there's not much I can do about it now. Comcast is just a piece of shit. I'm honestly surprised there even is an episode convert. It's too easy of a target for them, I would think. All right, I'll be right back. I'm gonna use the restroom, and we'll consider what we do for the rest of the afternoon. So, as usual, you only think clearly the moment you get up from the desk. Um, I don't think that this rank transform is a good idea, despite what the PLR paper says, because obviously for sparse reward environments, most of the rewards are going to be 0, and you really care about capturing that big spike in advantage. I think that this rank thing makes more sense for denser ends, or perhaps if you're not normalizing your advantages. Hopefully the advantage norm thing is interesting as well. I actually think there's probably a lot more to get just from playing around with the advantage norm and stuff. Just talent sort. That's funny. Okay, so that'll run. I guess can we think about advantage normalization for a second? Internet. We currently norm the advantage, right? I think that the better thing to do would be to normalize versus what, like a running mean of discounted reward? Mean and standard deviation. Interesting. Raw advantage, huh? Raw advantage is also sketchy. Well, I've wanted some time to play with a few things. But maybe we'll just play with a few things here. So first of all, let's take state sets off. And you just play with a few algorithmic things. And we have stable breakout, right? Hmm. Funny that totally messes up learning, huh? That reward clamping kernel. Okay, we'll leave this for now. What about advantage normalization? Now we're just playing with a few different things right now, Jess. There are a few little tidbits of things I wanted to sort of just play around with. Okay. Is this, no, this is just the big kernel, isn't it? Where are we computing our advantage here? Well, here we are. I see, yeah. It's fused. Does anybody have ablations on advantage norm, I wonder? Can we replace it with something? Yeah, it's probably fused into the loss. One of the problems with this repo. This. I do wonder, like, it's probably not reasonable to expect this to work without retuning hypers, right? Oops. I don't believe that it actually applied it, did it? Oh, it did apply this. Hang on. It says this built. Okay, I mean, that is interesting, isn't it? Should we test a small problem with this? You would just be able to remove a lot. Obviously, we're not going to be able to just, like, ship this on its own. Mm-hmm. I'm actually very surprised that trains just as well. This should actually fix the entropy bullshit as well, right? What entropy bullshit? So normalizing the advantage, um, even when there's zero reward, was forcing the policy weights to shift all around, and it was essentially determinizing the policy, even with a small entropy bonus when there was nothing to optimize. Okay, this messed up this, which is interesting. Advantage is supposed to be error in the value function, right? I'm trying to think if you would scale by mean, like running mean or what. You don't want to change the target. Wait. Hey, look at this. This literally just cited. This just cited my own paper. Look at this. Codex just cited my own paper. Isn't that funny? Oh, hang on, Spencer. You know what's really funny, though?